Hey, in today's video, I'm going to recap on college matriculation physics semester 1, and this is on the topic of forces, chapter 4. So in front of me, I've got a plane, and this plane contains a block. So that block is pushed upwards with a force of F, and it's on an incline plane of 25 degree. Alright, so the question is to find the magnitude of force F and also to find the normal force exerted on the block. So to answer these kind of questions, the first thing that we need to do is to determine what our axes are. So with this type of questions, because it's slightly inclined, it's easier to redraw this, our x and y axis, as this. Right, so this plane is your x-axis, whereas that plane like this is your y-axis. Yeah, I think from that hopefully you understand until that. All right, so next I do want to know which, because I want to draw my free body diagram. So before I do that, I need to know what's my fx, right, and also what's my fy is on the projection of my y and x axis. So to do that, I'll just need to draw line from my y axis onto f. So if I do this and putting it like that, yeah, and putting that as 90 degree. So seeing this, you might be confused, like, hey, where do I put my 25 degrees, right? Is that angle here or is that angle here? Well, I just realized that you can do that by just draw it really nicely and maybe do your drawing sharply. For example, and hopefully if you don't understand what I'm trying to do, that's okay. I'm trying to learn how to teach, and hopefully one day I'll be able to teach really clearly. But if I draw my triangle bigger like this, and this is very sharp 25 degrees angle, and I draw normal to this one, so this is y-axis and this is my x-axis, and then I have my force just like this one. And just like that, just now I did draw my 90 degree angle. Let's say I draw it from here to here. So that's my 90 degree angle. And from this side, we know and we can clearly see that this is the shorter side, right? So this is the shorter side, whereas the more pointy one is on this side. So that means our angle is on this side. So if you ever confused on which angle you should place, either this side or that side, just consider drawing your triangle a bit more pointy, and hence you'll be able to see. Alright, let me clear that up. Alright, now that we establish that this is our theta, the same as our theta right here, we can now resolve that free body diagram. So if I have a projection on the adjacent of my theta, then that's f to cos theta, whereas this is f sine theta. And remember, this is the weight, and hence if this is the theta onto the weight, let me draw that again. Yeah, if that's the weight, then this line right here is w cos theta, whereas this one is w sine theta. Hopefully that makes sense. Yeah, and the question also said that the plane is smooth, so which means we do not have f to the what do you call that, the rough surface which have the coefficient mu. We don't have that. Alright, now what do we do? To draw this more clearly, I really like to redraw my free body diagram one more time. So let me redraw that. I have my n here, I've got f sine theta here, and then I've got w cos theta here, and then on the right side I have f cos theta, and then on the right side I actually don't have anything. Alright, so that's my free body diagram. That looks good. So we can try and find and solve the first question, which is to find the magnitude of force F. Let's do that. What I like to do actually is to divide this into two I'm sorry, actually we've got w sine theta in here. Alright, what I like to do is divide this column into two, your x-axis or your y-axis. So with my drawing right here, I've got the total of x is to, remember this is just your Newton's second law, so I'm just writing that down. On the x-axis, what do I have? I have f cos theta minus w sine theta is equal to ma. But since the question is saying that the horizontal force, the block is actually, this is in the question, the block moves with, sorry, you can't see that. Oops. The block actually moves with constant velocity. So if it's moving with a constant velocity, it means that a is actually 0. So what I have is now f is just w sine theta divided by cos theta. What am I saying? So w is just mg, and sine theta over cos theta is just tangent theta. So that's my f. So put that into calculator, and knowing that my block has a mass of 3 kilograms, let's put that into calculator. Times tangent 25, I got 13.72 Newton. Yeah, so we got to find the magnitude of the force, which is 13.72 newtons. So that's the force. Now, how do we find the normal force exerted on the block? Well, from the y-axis, we know that our n minus f sine theta minus w cos theta is equal to ma. And once again, because the block is not moving upwards, like it's not flying upwards or going downwards, which means the position in x and in y-axis actually is the same. So our acceleration in that regards is actually 0. So we can rewrite n as f sine theta plus w cos theta. And if I plug everything in, sine 25 plus 3991 times, I do not have enough space. Yeah, if I click that real quick on the calculator, I get 22.47 Newton. So that's my normal force. Yay! So we answered two parts of this question. So just to recap, to find the magnitude of any force, actually this part is a bit more geometrical, and let me show you another way to find the angles between that two. And this is one that I just realized that I need to do to make my student understand. let me call this how to find the angles. Yeah, so let's say you have an angle here, right? What I did just now, with f going this way, firstly I established that this must be my x-axis, and normal to that must be my y-axis. And what I did was to create a 90-degree angle from y to f. So let's say this is a 90-degree angle from this side. Yeah, so this is 90-degree angle, and straight away I know this is the shorter part, and hence this must be the angle. If you compare the triangle number 2, let's call this triangle number 2, and this is triangle number 1. Yeah, the more teros, or we say the sharper ends, must be the angle. But what if I do it the other way around? Let's draw the same triangle, and then draw this, and then this. Ooh, that looks not nice. That doesn't look nice. Ooh. Okay, good enough. What if I were to draw the 90-degree angle from here? Right? So this is the shorter part, and hence the angle should be here, right? Can we still project that to our x and y-axis? And if we can, how would we do that? Well, basically, if I were to do this, my f is right here, and hence I can't really see clearly how I would do to project my f onto this part, right? How I would normally do that is I assign a new variable of the angle. Let's say let's say an alpha. So my value on this side of the triangle will be f cos alpha, and obviously if this is f cos alpha, then the x-axis of that, or orthogonal, we call it orthogonal to that, is f sine alpha. Well, surprisingly, f cos alpha we can rewrite as f sine theta. Where's this one? F sine alpha we can rewrite as f cos theta. Now you might be wondering, how is that even possible, right? So let's do an experiment. Let's say you have an angle here, which is 50, and this is 40, and this is 90, right? So in the total, in a triangle degrees is 180. So that should be correct. With this logic, I would say that if I call this an angle as theta, just theta, and it's alpha, then I'm saying that if I have f is equal to 3, then f cos of 50 must be equal to, because I'm projecting it here, must be equal to f sine of 40. Is that correct? Well, if you press your calculator, that's 0.6427, and sine of 40 is also 0.6427. So yeah, well, cases 1, check. You can do for all angle and see if you get the right answer. But this is how you would find the angle if you ever get confused. Well, to recap, we look at the block, and we look at more complicated version of the forces that we need to resolve first, and to be able to answer. and we managed to find the magnitude of F, and we managed to find the normal force exerted on the block using a free body diagram. Hope you find this useful. If you ever have a question or certain part of my explanation do not make a clear sense to you, you can always chat in the box. Thank you.